This is a Qatar Airways Airbus A350-1000, and it's preparing to depart from Doha to Los Angeles. That's around 7,200 nautical miles, close to 16 hours in the air, crossing continents and oceans in a single, uninterrupted arc. But here's what makes this flight especially interesting. Qatar Airways also operates more than 50 Boeing 787 Dreamliners, a fleet size comparable to its A350 family. And yet, you won't see a 787 regularly assigned to this Los Angeles service. Why? Because airlines don't choose between the A350 and the 787 the way most people imagine. They're not picking a favorite aircraft. They're solving a multi-dimensional strategic puzzle with range, economics, fleet structure, cargo demand, and even engine politics, all moving at once. Once you understand how those pieces connect, you begin to notice patterns, not just at Qatar Airways, but across the entire global aviation industry. At first glance, the Airbus A350 and the Boeing 787 appear almost interchangeable. Both are next-generation, twin-engine, wide-body aircraft, built largely from composite materials. Both were designed to replace older, less efficient jets like the 777-200E, A350, and 767. Both promise double-digit improvements in fuel burn and passenger comfort. But beneath that surface similarity lies a far more nuanced reality. When airlines make billion-dollar fleet decisions, small differences in range, payload, weight, cockpit commonality, and engine strategy become decisive. The aircraft may look similar from 30,000 feet, but strategically, they serve different missions. Let's start with the most fundamental factor: range. The Airbus A350-1000 offers a published range of roughly 8,700 to 9,000 nautical miles depending on configuration. The Boeing 787-1000, its closest size competitor, offers about 6,330 nautical miles. That difference, well over 2,000 nautical miles, is not marginal. It reshapes what routes are physically possible. Ultra-long-haul sectors like Doha to Los Angeles, Singapore to New York, or future non-stop flights from Sydney to London demand not just fuel efficiency, but enormous fuel capacity, combined with high maximum takeoff weight. The A350-1000 was engineered with that capability at its core. This is precisely why Qantas selected the A350-1000 for Project Sunrise, its ambitious plan to connect Sydney non-stop with London and New York. The 787-9, which Qantas already operates successfully on long-haul routes, simply could not perform those missions with full commercial payload. It would have required severe weight restrictions, reducing passengers or cargo. The A350-1000, with its higher maximum takeoff weight and structural capacity, made those routes economically viable rather than merely technically possible. In aviation, that distinction matters enormously. A route that can operate profitably becomes part of a network. A route that cannot turns into a marketing experiment. However, range alone does not decide fleet strategy. If maximum range were the only objective, airlines might all gravitate toward the largest, longest-range aircraft available. But operating an aircraft designed for extreme missions on shorter routes introduces the A350-1000 carries the structural reinforcement, heavier landing gear, and fuel tank capacity required for ultra-long-haul, flying everywhere it goes. On a 6 or 7 hour flight, much of that capability becomes unused weight. Weight translates directly into fuel burn. In contra, the 787-10 was optimized for medium to long-haul missions under roughly 6,000 nautical miles. On those routes, it often delivers superior seat-mile economics. Think of it like this: owning a vehicle capable of towing massive loads is invaluable when you need that strength. But if most of your daily trips involve light errands, you're carrying extra capacity you rarely use. Airlines analyze routes in the same way. A350s excel on missions that stretch the limits of commercial aviation. 787s shine on dense, high-frequency routes where efficiency and quick turnarounds matter more than extreme range. This creates a natural segmentation. Airlines focused heavily on ultra-long-haul or high-premium fortress hub strategies tend to favor the A350-1000 for flagship routes. Airlines prioritizing point-to-point expansion between secondary cities often lean toward the 787 family, particularly the -8 and -9 variants. which combine flexibility with strong economics. But the decision becomes even more complex when you consider fleet commonality. Airlines do not purchase aircraft in isolation. They invest in ecosystems, training programs, spare parts inventories, maintenance infrastructure, simulator fleets, and pilot qualification pipelines. Airbus has long emphasized cross-crew qualification across its widebody family. Pilots certified on the A330 can transition to the A350 with relatively limited additional training in certain jurisdictions. That shared cockpit philosophy reduces training costs and enhances scheduling flexibility. Airlines can maintain a unified pilot pool rather than separate silos. This played a role in Delta Airlines' transition toward Airbus Widebody. After inheriting a 330 aircraft through its merger with Northwest Airlines, Delta expanded into the A350 rather than doubling down on Boeing A350-1000. The commonality between Airbus platforms simplified crew planning and long-term operational alignment. Boeing, of course, offers its own ecosystem advantages, particularly for airlines operating the 777. There is operational familiarity between the 777 and 787, though the cockpit philosophy differs more than Airbus' cross-family strategy. So when an airline evaluates the A350 versus the 787, it isn't just comparing performance data. It's examining its existing fleet. If the airline already operates a 330s, the A350 becomes a logical extension. If its long-haul backbone consists of 777s or earlier 787 variants, expanding within Boeing's ecosystem may make more sense. Fleet commonality can outweigh marginal performance differences because it impacts staffing, resilience, and cost control over decades. Now let's examine Qatar Airways as a real-world case study. Qatar operates both aircraft families extensively. Its A350 fleet includes both the -900 and -1000 variants, while its 787 fleet includes the -8 and -9. Rather than favoring one manufacturer, Qatar deploys each aircraft type where it performs best. On ultra-long-haul sectors such as Doha to Los Angeles, the A350-1000 dominates. On shorter long-haul routes to European destinations like Barcelona, Dublin, or Frankfurt, the 787 frequently appears. The deployment patterns reflect route economics. The A350 fleet, on average, flies longer sectors than the 787 fleet. That's not coincidence. It's optimization. Aircraft assignment is the result of detailed modeling involving passenger demand, cargo potential, slot constraints, and turnaround efficiency. Qatar uses the A350 when range, cargo capacity, and premium cabin volume are decisive. It uses the 787 where frequency, flexibility, and cost control take priority. Cargo adds another layer to this equation. The A350-1000's wider fuselage cross-section allows for greater lower-deck cargo volume. In certain configurations, it can carry significantly more freight than a 787-10. In the post-pandemic aviation environment, cargo revenue has become a critical contributor to long-haul profitability. Airlines with strong freight divisions evaluate aircraft not only by passenger seats, but by container positions and payload limits. On routes linking manufacturing centers in Asia with consumer markets in North America or Europe, additional cargo capacity can meaningfully improve margins. Engine selection introduces yet another strategic variable. The Boeing 787 offers airlines a choice between General Electric's GEnx engines and Rolls-Royce's Trent 1000 engines. The Airbus A350, by contrast, is powered exclusively by the Rolls-Royce Trent XWB. Having two engine options gives airlines negotiating leverage and diversification. However, history has shown that engine reliability can significantly influence fleet decisions. The Trent 1000 program faced well-documented durability issues, resulting in aircraft groundings and operational disruptions for several carriers. Consequently, many recent 787 customers have favored the GEnx engine for its perceived reliability track record. The A350's Trent XWB, designed specifically for that airframe, has generally demonstrated stronger in-service performance, yet airlines purchasing the A350 do not have alternative engine suppliers. That lack of choice affects negotiations around maintenance contracts and long-term support agreements. When Emirates evaluated the A350-1000, discussions included engine performance, guarantees and cost structures. On orders worth billions of dollars, these factors weigh heavily. When you zoom out, a broader pattern emerges. Airlines that aim to open entirely new, long, thin routes between secondary cities often gravitate toward the 787's flexibility and lower trip cost. Airlines that concentrate traffic through powerful hubs and rely on premium-heavy, high-yield, ultra-long-haul markets frequently value the A350's additional range and capacity. Hybrid carriers like Qatar Airways strategically operate both, matching aircraft to mission with precision. Neither aircraft is universally superior. Each was engineered with different priorities. The Boeing 787 emphasizes efficiency, versatility, and network experimentation. The Airbus A350 emphasizes range, payload, and flagship long-haul dominance. Airlines are not choosing between better or worse. They are choosing which tool best aligns with their long-term network vision, and that's the deeper insight. Aircraft selection reveals airline strategy more clearly than advertising campaigns or press releases ever could. A fleet dominated by ultra-long-range aircraft signals ambition to connect distant city pairs non-stop. A fleet centered on flexible mid-size wide bodies signals a focus on frequency and network breadth. Fleet planning is, in many ways, a public blueprint of an airline's future. So the next time you see a Qatar Airways, a A350-1000 taxiing for departure to Los Angeles, while a 787 boards passengers for a European flight nearby, remember that difference is not random. It is the visible outcome of years of data modeling, cost analysis, and strategic forecasting. Airlines are not simply buying airplanes. They are designing the architecture of their global networks. In the end, the choice between the A350 and the 787 is less about brand loyalty and more about mission design. It's about how far you need to fly, how much you need to carry, how your crews are structured, and what kind of network you want to build over the next 20 years. One aircraft enables experimentation and efficient expansion. The other enables endurance and market-defining ultra-long-haul service. Both represent the cutting edge of modern aviation engineering, and together they illustrate a powerful truth. Airlines don't choose aircraft, they choose futures.